This is 8G1-4 video notes. We're going to start with just reviewing some rules for transformations. I'm going to quickly go through just this list here. Rigid transformations, which we also can call congruent transformations, keeps the same shape and size. It keeps the shape congruent. These include translations, reflections, and rotations. We're going to do some examples. For a translation, if we're going to move right 7, that means the x value is going to add 7, but y stays the same. If we move left 4, then the x value subtracts 4, the y value stays the same. If we move up 5, then the x value stays the same and the y value adds 5. If we move down 3, then the x value stays the same, the y value subtracts 3. Next, we have reflections over the x and y axis. For reflection over the x-axis, xy goes to x negative y. So x stayed the same, the height changed. For a reflection across the y-axis, it swaps left to right, so the x changes, but the height stays the same. Now for rotations, a 90-degree clockwise rotation goes to y negative x. It takes the original y and writes it first, and it changes the sign of x and writes it last. 180 degrees just changes both the x and the y signs. And then a 90-degree counterclockwise rotation changes the original y sign and keeps x the same. Our last type of transformation is called a similar transformation. It's not rigid. So it keeps the same shape as all of these do, but not the same size. The size changes. It keeps the shape similar. Same shape, but different size. So this is called a dilation. And we use a dilation about the origin. So let's look at an example of a reduction. We're going to reduce by a scale factor of 1/2. So it's going to make it half the original distances. So half of x and then half of y. It's just multiplying by half. And then let's enlarge by a scale factor of 2. It's going to double each distance. So 2 times x, 2 times y. Standard 8G1 is about congruent sides and angles. So number 2, which of the following statements is true about the angles and side lengths in a figure when the figure is reflected over a horizontal line? In a reflection, both angles and side lengths stay the same. That's true of translations, reflections, and rotations. Number 4, which figure is a translation of figure 1? That just means it is a slide of this figure 1. And none of them are. Number 5, the side lengths of the quadrilateral CDEF are as follows. The figure is rotated 180 degrees. What are the side lengths of the resulting figure? So it's just a rotation. They stay the same. So C prime D prime is 4 centimeters. D prime E prime is 5 centimeters. E prime F prime is 8 centimeters. And C prime F prime is 7 centimeters. Number 6. In the figure ABC, angle A has a measure of 60 degrees. What's the measure of angle A prime after a translation and a reflection? So these do not change the angle measures. They stay the same. So the measure of angle A prime is 60 degrees. Standard G2 is about congruent figures and sequences. Number 1 says, is figure ABCD congruent to figure KLMN, and explain? Well, when we look at these, ABCD and KLMN, they are different shapes. So no, they're different shapes. Number 2, is figure ABCD congruent to, so we have ABCD, is that congruent to PQRS? And you can look at these and tell that there's been a rotation. So yes, they are congruent. They are same size and shape. Standard G3 focuses on transformation rules. So looking at number 1, it says graph and label the image of figure ABCD after a translation 4 units left and 3 units down. So it says XY goes to X minus 4, Y minus 3. We could actually just count these, however. We could say point A goes goes left 4, down 3. So left 4, down 3, plot point A prime. Point B, left 4, down 3, plot B prime. Point D, left 4, down 3, plot D prime. And then C, left 4, down 3, plot C prime. All right, number 2, what's the rule that describes the translation that maps triangle LMN onto L prime, N prime, N prime? So we're going from this original triangle LMN to the new one. We need to figure out what's happening. Okay, so first of all, let's notice that from M to M prime, I could pick any point, that I'm going to the right 1, 2, 3, 4, 5 places. So right 5 units. And then I'm going up 1, 2 places, so up 2. So 5 units right and 2 units up, answer choice A. Number 5, quadrilateral EFGH is rotated 270 degrees, and we're going to call this counterclockwise for our notes about the origin. Draw the image and label its vertices, E prime, F prime, G prime, H prime. So we have a rule for 270 degrees counterclockwise, which is actually the same for 90 degrees clockwise. Now we could go to our rule and we could say, well, I know XY goes to, what if I forget this? And I think, well, I know X and Y swap places, but what are my signs? So I'm going to think clockwise goes around like a clock. It's going from a positive X, negative Y to the third quadrant, which is negative, negative. And I could go ahead and list my ordered pairs, E, F, G, H, where E is 3, negative 2, F is 3, negative 4, G is 1, negative 4, H is 1, negative 3. And I'll go through and figure out what those go to. And this is a strategy we can use if we forget our signs for the swapping X and Y. I can say, okay, well, if I can ignore the signs a minute, I have 2 and then 3. I'm just swapping X and Y, and I know they've both got to become negative, so they're going to be negative, negative. So that's what this means. We look at our Y value first. It was negative 2 and it stayed negative 2. Great. Then we look at our X value. It started as 3, it became negative 3. So we've got to place this negative sign. Now I'm going to use that for the rest of the ordered pairs. So I'm going to go through and get all these first coordinates first. These Y's were negative 2, negative 4, negative 4, negative 3. They stayed the same. Negative 2, negative 4, negative 4, negative 3. Then I'm going to look at the X's. I had 3, 3, 1, 1, but they changed their sign to be negative 3, negative 3, negative 1, negative 1. Now I just plot these points. Negative 2, negative 3 was point E prime. Negative 4, negative 3 was F prime. Negative 4, negative 1 was G prime. And negative 3, negative 1 was H prime. And we have finished this problem. Standard G4 is focused on dilations. We're going to look at this number 2. It tells us about triangle ABC and its side lengths and angles, and triangle DEF and its side lengths and angles, and asks if they're similar. Similar figures have the same angle measures or shape, but the sides will change their measures. So if we look at triangle ABC, we have angle A is 53 degrees, where in triangle D, angle D is 53 degrees. Looking at B, it's 90 degrees. Angle E is 90 degrees. Angle C, is 37 degrees. Angle F is 37 degrees. So are these similar? Yes. They have the same angles, which means they have the same shape. And let's figure out the scale factor. So erasing all of this and looking at triangle ABC, I'm going to start with AB. Well, AB is 3 units and DE is 9 units. BC is 4 units. EF is 12 units. AC or CA is 5 units. DF or FD is 15 units. Every time they're multiplying by 3. So they have the same angles or shape and a scale factor of 3. Are these triangles similar? Well, starting with ST, it's 6 units, and SQ is 12 units, so it's double. TU is 3 units, and QR is 6 units, so it doubled. And then SU is 5 units, and SR is 10 units, so it doubled. So are they similar? Yes. Sides are doubled, or they're multiplied by a scale factor of 2. On our last problem, number 4, select all true statements about an image after a dilation. Well, the first says the image is a different shape. That's not true. The shape stays the same. The second says they're a different size. That is true. A dilation does change the size. The third says they have the same angle measures. That is true. The shape stays the same. The next one says they have the same orientation, which means that it doesn't slide, flip, or turn, and that is true if it's only a dilation. The next one says they are similar. That's true. Same shape, different sizes. The last says they have the same side lengths. That is false. The sides do change.